students. In today's revision, we are going to see rules for obtaining images formed by spherical mirrors. First rule is, in a concave mirror, a ray parallel to the principal axis will pass through its principal focus after reflection. And in case of a convex mirror, a ray parallel to the principal axis will appear to diverge from its principal focus after reflection. Now the second rule is, a ray passing through the principal focus of a concave mirror, this is the principal focus, will become parallel to the principal axis after reflection. And in case of a convex mirror, a ray directed towards the principal focus of a convex mirror will emerge as parallel to the principal focus after reflection. The third rule is, a ray passing through the center of curvature of a spherical mirror, that means it is also in case of a concave mirror and a convex mirror, will reflect back on the same way from which it has come, because it always is always incident on the mirror at an angle of 90 degree. Now rule number 4, a ray of light which is incident at the pole of a concave mirror or convex mirror is reflected back, making the same angle with the principal axis. That means this angle I will be equal to angle R in case of both the concave mirror also and the convex mirror also. Now we are going to see image formed by a concave mirror. The first is, when the object is at infinity, always we consider that the rays which are coming from a distant object, that means from infinity, they are parallel to the principal axis of a concave mirror or a spherical mirror. So when these parallel rays are incident at a concave mirror, they will be converged at a point which is called the principal focus, and this image will be on the focus sharp, highly diminished, and will be highly diminished. Second, when the object is placed between infinity and beyond the center of curvature, here one ray we are going to consider which is parallel to the principal axis, and the one ray which is passing through the center of curvature. The ray which is parallel to the principal axis will pass through the principal focus of the concave mirror, and the point at which these two rays are intersecting, at that point we will get the image formed. In this condition, we are going to get a real inverted image which is smaller than the object and which will be formed between center of curvature and principal focus of the concave mirror. Now the third situation is, when the object is placed at the center of curvature of the concave mirror. Again, one ray we are going to consider which is parallel to the principal axis, and the another ray is passing through the principal focus of the concave mirror. The ray which is parallel to the principal axis will go through the principal focus after reflection, and the ray which is passing through the principal focus will become parallel to the principal axis after reflection. At the point of intersection of these two rays, this will and this one, we are getting an image at the center of curvature, that means the point at which the object was placed, and now the size of the image will be the same as of the object, so we will get the same type of size of image here at the same place where the object is placed. Situation 4, when the object is placed between the center of curvature and focus of the concave mirror. Again, one ray will be considered as which is parallel to the principal axis, and one ray which is passing through the center of curvature of the mirror. The ray which is passing through the center of curvature will reflect back on the same path, and the ray which is parallel to the principal axis will pass through the principal focus of the concave mirror, and the place where these two rays are intersecting with each other, we are going to get an image of the real and inverted image of the object which is highly magnified. And we found it beyond the center of curvature. Situation 5, when the object is placed at the principal focus of the concave mirror. Again, one ray which is parallel to the principal axis and the another ray which is passing through the center of curvature of the concave mirror. This ray which is passing through the center of curvature will reflect back at the same path, and the ray which is parallel to the principal axis will go from the principal focus of the concave mirror. These two rays will be parallel to each other, so and the image so formed will be found at infinity, and it will be highly magnified. The last position is when the object is placed between the focus and the pole of the concave mirror. Here we can see that again we are considering one ray which is parallel to the principal focus, principal axis, and the ray which is passing through the center of curvature. Here we can see that we are going to get a virtual and erect image behind the mirror. The ray which is parallel to the principal axis is passing through the principal focus of the concave mirror, and the ray which is passing through the center of curvature will appear to come from this point. That means these two rays are intersecting behind the mirror. It appears that they are intersecting here, and this is how we are going to get a enlarged image of and virtual and erect image of the object behind the mirror. This property of a concave mirror is used in shaving mirrors also.